Hi, this time we're going to be looking at an extension of the previous video where we don't have clear solutions. We've seen that we can solve systems of 3 by 3 equations using matrices. We can actually extend that method to 4 by 4 or n by n or even m by m. N by m where we have different numbers of equations to unknowns. We can also go backwards to 2 by 2 if we really wanted to. And with a 3 by 3 system, in just the same way as with a 2 by 2 system, we have times when there isn't necessarily a clear solution. So let's have a look at this system. We have 3 equations in 3 unknowns, and again, we need our augmented matrix. So here it is. And remember, we need to get zeros here to start with. So I'm going to say row 2 minus 2 row 1, and I'm going to say row 3 minus 3 row 1. So here's our instructions, and here's the results. So getting my 0 here, I'm going to say row 3 minus 2 times row 1. And there's our finished result. We've got zeros all the way around here. Problem is, that last line gives us the result essentially of 0x plus 0y plus 0z equals 5. So multiplying something by 0 to get a number, not possible, isn't going to work. So in this case, where we've got zeros and a number, then this system has got no solutions. There is no way of solving this. Okay, what about this one? Again, our augmented matrix, here it is. And it's going to be row 2 minus 2 row 1 and row 3 plus 3 row 1. Here's our result. Well, again, we've already got zeros here and here, so something weird's already happening. And if I say row 3 plus 11 row 2, I get zeros all along the bottom. So basically, I've got 0x plus 0y plus 0z equals 0. That's fine. We can handle that. That makes perfect sense. But our second line, we've basically got 0x plus 0y equals minus 2z, or plus minus 2z, equals 0. In other words, in this case, z equals 0. But what about x and y? Well, what we do is we actually set up a parameter, if you like, another variable that we use to link x and y. And I'm going to say in this case let y equal t. Our parameter is t. So our top line then becomes x minus 2 times t plus 5 times 0 equals 1. In other words, x is 1 plus 2t when I rearrange it all. So we've got the solution x equals 1 plus 2t, y equals t, and z equals 0. So what does that mean? Well, basically, let's say t equals 0. We would have 1, 0, 0. If t is 1, we've got 3, 1, 0. If t is minus 10, we've got what? That's minus 9, minus 10, 0. So depending on what t is, it will fix what x and y are, but as long as they're in that relationship, then they are possible solutions to this system. In other words, we have got an infinite number of solutions when it's the case of all zeros across the bottom. Geometrically, we can think about what those 3 solutions mean. We saw with the 2 by 2 system that we could have, they intersected a point, they were parallel, or they were coincident. Well, there's a few more possibilities here. Those of you doing specialist maths hopefully recognize what we're dealing with. We've got ax plus by plus cz equals d, and that's just the equation of a plane in 3 dimensions. So what we're doing when there is a unique solution, we've got 3 equations, or 3 planes, unique solution, they are meeting in a point. So we've got our 3 planes all meeting at one point. But what if there's an infinite number of solutions? Well, if it's infinite, then they actually intersect in a line. So we have this set up so that all three intersect on the same line. So anything on that line actually fits. And if there's no solutions, well, there's actually several possibilities, and here's a couple. It could be this situation where we've got two parallel planes and another one going through them. Well, there is nowhere where all three planes meet. We might have all three of them parallel, so clearly there's nowhere where they meet. Or we could have perhaps this situation where all three or any pair of planes meet in a line, and that line happens to be parallel to the other plane. There are a couple of others, and if you want to know what they are, ask the spec students, because these diagrams, hopefully they recognize them, actually come out of the spec textbook, and they will show you a couple of other possibilities. But if we've got zeros all across the bottom, then we've got infinite solutions and we have to set up parametric equations. If there are 3 zeros and then a number, then there are no solutions. And that is pretty much it. Exercise 9D has got lots of practice of those with 3x3 systems, and the other exercises start looking at 4x4, plus there's some worded problems for you to actually generate equations and then solve them. So have a go, enjoy.